Hello guys, in this Genius Fellow Studio with another video. Today we'll be talking about stars and galaxies. There are, like how I said, there are many celestial objects in our solar system, but now we'll be moving out and scaling out of our solar system and move into stars and galaxies. Stars and galaxies are really more complex, harder to understand, and also more awesome, more wonderful, more amazing objects which are unbelievable to the human brain. So first we'll be talking about stars because that's the smallest out of stars and galaxies. Stars are pretty awkward in a way if you think of it. We on Earth we believe that red is hot and blue is cold. But in our solar system, it's the exact opposite because red stars are usually colder and blue stars are usually hotter. So this is a really awkward, but it's true that um, red stars are cold and blue stars are hot, and that actually does make sense because if you think of it, blue is actually a bright color, bright in contrast and brightness, and red is a more duller color. And because of this, red, because it's a dull and not so bright color, it is cold, and blue is a more hotter color because it's more brighter. And you may be thinking that because red is cold, shouldn't red stars be bigger because there's not that much energy needed to make the star hot. So that's why wouldn't it be bigger, and wouldn't blue stars be smaller because more energy is needed to keep itself hot? Well, actually, in our solar system, it doesn't. It kind of works like that because there are many red dwarfs. There are many red dwarfs, which are really tiny and are really cold. And then there are blue giants, which are huge blue stars, which are super bright. But then there are also blue dwarfs, which are usually is the outcome of a star's death. And then there's also red giants, which actually occurs during the death of a star. So it's kind of a mix and it's an awkwardness of stars. But this is what makes them amazing to learn about. So let's learn more about stars and some famous stars that we know a lot about. First, we'll be talking about our sun. So our sun gives all the life needed for our Earth to survive. Without the sun, we wouldn't have photosynthesis that wouldn't help us purify the air, and it wouldn't help us. It wouldn't help us. We wouldn't have plants and animals to eat, and we wouldn't have vitamin D to survive. The sun, because of this, because the sun releases a lot of hot solar winds, which um give light, and so it helps. The sun's core is about 53 million degrees Fahrenheit. 53 million degrees Fahrenheit because it's so compressed inside the core that there's so much of pressure that it's so hot. And on the surface of the sun, it is about 10 million degrees Fahrenheit. So it's, it's really it's really awkward in a way, like 43 million degrees Fahrenheit just because of the core. Well, that's because the sun is really huge. Let me explain this. On the surface, when a whole bunch of energy is released, if this were the surface right here, a whole bunch of energy is usually released into the air. But then because of gravity, it curves back down and comes in like that. These are called solar flares. These solar flares release so much of heat that they cause solar winds and solar storms to form. And each of these solar flares can fit 10 Earths. I'm going to say it again. It can fit 10 Earths inside it. So that is a really huge measure. And that's how big the sun is, that just in a tiny solar flare, which you can barely even see on the sun, can fit 10 Earths inside it. So that's a special fact about our sun. And you can learn more about our sun inside the article in the comments and description section. in the article. Next, we will be talking about. Wait a second. Just gonna do this, and then I'm gonna. Now we're gonna be talking about Proxima Centauri. Proxima Centauri is the closest planet to the Sun. It's 4.3 light years away. So that's the closest planet to our Sun. And based on scaling the universe, although it's 4.3 light years, that's still a really far distance for human study and technology. Anyways, 4.3 light years. Proxima Centauri is in part of a three-star cluster, and Proxima Centauri is a small red star inside a three-star cluster, which is made up of another two huge red giants. One is Alpha Centauri, the other one is Alpha Centauri B. And Proxima Centauri is a small red dwarf, which is smaller than our sun. So if we were to measure it, our sun would be about this much bigger. So our sun, Proxima Centauri, is a pretty small star and doesn't release that much of light because it's red. And it's pretty cold compared to the sun, but don't mistake it cold as really, really, really cold. Next, we'll be talking about Cyrius. Cyrius is the brightest star in the north in our sky, or what we call the North Star. Yes, this is the North Star. Well, you'll be wondering, Sirius isn't close to our Earth. So how is this the brightest star in our night sky? Well, this is because Sirius is a blue giant. It's a blue giant, so it is really hot and bright. And also, because it's really big, its solar system's radius and diameter will also be a lot. So if this is Sirius, its solar system would be this much. And if this is our sun, our solar system would be about this much. So because of this, Sirius' solar system is close, its boundaries are closer to our solar system. So although the star itself is far away, its solar system's boundaries are close. And that's why it is the brightest star in the night sky, both because it's hot and bright, and also because its solar system's boundaries are close to our sun and to us. Now we'll be talking about one of the hugest stars, Betelgeuse. Yes, Beetle Juice. Like beetle juice, like a juice, drinkable juice, which is made of beetles. Yuck, that's gross. But it's not spelled that way. It's spelled this way. Beetle juice. So although it is called Beetle Juice, its spelling is totally different. Anyways, Betelgeuse is a huge star which is thousands and thousands of times, or maybe even millions of times bigger than our sun. And it is famous because if it were to die, its supernova would be so huge that it would light up our whole night sky. That's how bright it is. And Betelgeuse is a red giant, so it's not so hot, but it's also not so cold. So it's a red giant. And for some reason, it's been dimming. It's dimmed like in the early 2000s, and it's brightened all of a sudden. Scientists believe that mostly believe that it's a big cloud of dust that's blocking it. And then when it moved, the big cloud of dust moved away, then Betelgeuse was back to its bright, not so bright, but pretty bright self. But now it's been dimming again all of a sudden. So scientists believe that it's dying right now. And it may have died thousands of years ago because it's really far away from our sun, and due to like light physics, that it makes sense. But based on light, it may die today or tomorrow, but it may have actually already died a long time ago. That's pretty much it about Betelgeuse. And now we'll be talking about the last star in our list, which is Vega. Vega is Vega is the fifth most brightest star in the night sky. Vega is also the second brightest star in the northern hemisphere. Interestingly, it has also been the first star other than the sun to be photographed and spectrum recorded. It is also a variable star. It is one-tenth the age of the sun, but at the same time, due to its size and mass, it will also have one-tenth the lifetime as the sun. And because of this, this makes the star equivalent to the sun in a way, although it is thousands and thousands of miles bigger than our sun. Vega also has a fast rotational speed, so it is unpredictable to tell its average temperature and other scientific properties because its photosphere gets bulged out from the equator. And that's what you can see in the picture because its rotational speed is so much that its equator of its photosphere is bulging out a little. And it's the first ever planet to be recorded, photographed, and spectrum recorded. And it's one-tenth the age of the sun, and this also makes it one-tenth the lifetime of our sun. So it's pretty much equivalent, however, it's thousands of miles bigger than our sun. So that is pretty much it about stars. Now we'll be talking about galaxies. So there are lots and lots of billions and trillions and quadrillions and infinity galaxies in our universe, but we're going to be talking about four main and interesting galaxies first. First, we'll be talking about our galaxy, our home galaxy, the Milky Way. So the Milky Way is really famous for life because of us, and also because of its arms, which stretch out really far, and also its size is pretty big for a galaxy. Actually, really big for a galaxy, but not super big. So that's pretty much it about the Milky Way galaxy, and its radius is about 52,000 to 100,000 light years. Next, we'll be talking about the Andromeda Galaxy. The Andromeda Galaxy is slightly bigger than our Milky Way galaxy and is the first biggest galaxy in our galactic group. And our Milky Way galaxy is the second biggest galaxy in our galactic group, and that's just a fun fact you guys want to know. Our Milky Way galaxy and the Andromeda Galaxy are the two biggest and only biggest galaxies in our solar system, in our local galactic group. There are other small galaxies, but they're not so comparable. And another fun fact about Andromeda, the Andromeda Galaxy and our Milky Way Galaxy is that in the future, based on scientific theories, the Andromeda Galaxy and the Milky Way Galaxy will collide, creating an ultra huge galaxy that may or may not destroy life on Earth. Scientists aren't sure about that. Then we'll be talking about the Whirlpool Galaxy. The difference between a spiral galaxy and a Whirlpool Galaxy is that a spiral galaxy usually has really short arms and then it just fades like that. And that's it. But Whirlpool galaxies, as you can see in this picture, goes super long out and extends really far out into dark matter. And this pulls in lots and lots of matter into the sky, into itself. Special thing about the Whirlpool galaxy is this nebula. It's either a nebula or a small galaxy, a misshaped galaxy that has been becoming more and more misshaped due to the black hole in the middle of the Whirlpool galaxy that's been pulling out all the stuff inside that galaxy. So it's either a nebula or a minor galaxy. So that is why that's a special fact about the Whirlpool galaxy. Finally, we'll be talking about the Whirlpool. Excuse me, how many times are they going to say that? The tadpole that galaxy. Bleh. So the tadpole galaxy is special for this tail it has. Some theories state that a huger galaxy during the formation of the tadpole galaxy, a huge galaxy may have passed by, and when it passed by, it may have pulled a huge chunk of the nebula out into this line, and this line may have then formed and matured and then become into stars and other stuff. And that's how now it has this tail-looking thing. And even if you see this part over here, you can tell that something has pulled a huge chunk of cloud out of it. So this is a special fact about the tadpole galaxy and a special feature. And scientists believe that after thousands of years, this huge tail will fade and become a minor galaxy, and this galaxy will fully mature and become a normal spiral or whirlpool galaxy. So as you can see, our universe is really, really cool, and we should thank our universe because of this. And I hope you subscribed and liked the channel. Press the bell icon for more videos from Genius File Studio, and bye bye.